You guys find that in your packet? I didn't put page numbers in the packet for some reason. My bad. Bless you. All right, so we're not going to be dealing with quite the whole complexity of these equations yet. We're going to start with some simpler versions. We're going to be looking at this equation today, y equals b to the x power. Okay? And our goal today is two things. I want you to be able to understand how I can change this number b and what that does to my graph when I change it. Okay, at the end of the day today, if I give you an equation, and don't write this down, but if I give you an equation like y equals 0.8 to the x power, I want you to be able to sketch me a rough graph of what that looks like. And you'll be able to do that. Okay, so that's one of our goals, is for you to be able to look at this number here and know something about what the graph's going to look like. All right. Our other big goal is to introduce an idea of an asymptote, and that gets pretty complex. But we'll just kind of give an introductory definition of what an asymptote is. We're kind of dealing with calculus when we talk about asymptotes. So you guys ready for this? It's going to be awesome. Okay, here's what I need you to do. Can you please open up your computer, get to a web browser, and go to desmos.com. Desmos.com. When you do that, you're going to see a blue button that says Graphing Calculator. So I'm going to pause our video. We've got a lot of absent people. We'll come back after we. So one of our big goals for today was to know how does that b value in our equation, how does this b value right here change what the graph looks like? If I want my graph to be curving upwards, to be increasing, I want b to be, b is, say it one more time, higher than 1. Higher than 1. Do you guys remember how to do inequalities? Did you learn about the alligator back in middle school? Alligator always eats the bigger number. So if we want b to be bigger than 1, is the alligator going to be eating the b or the 1? If we want b to be bigger than 1, we want the alligator eating the b. So that's how we would write that if we didn't want to write out all those words. And we said if we wanted the graph to be curving downwards like this, what kind of values for b did we want? Lower than 1, but bigger than 0. How else could we write that? Yeah. Positive decimals. I like that, except I think technically something like 1.5 would still be considered a decimal, right? Because it's got a decimal in it. Under than 1, so positive numbers under 1, I like that. There's lots of different ways to write this. I'm going to write it this way. B is between what and what? 0 and 1. If I wanted to write that using this kind of notation, it would look like this. But as long as you can give me the words, it's between 0 and 1, that's fine. Now, if we're looking for an equation that looks like this that has a flat graph, b has to be a specific value. What value did you find was the only one that would give you a flat graph? 1. So b equal to 1 in that case. All right, so we're going to do a little quiz. Okay, I don't want anybody shouting out answers here because I want everybody to get a chance on this. In fact, you're not even going to write anything down. You're just going to think of answers in your head, but don't shout them out, please. Okay, so you can set your pencils down for a minute. Look up here. I'm going to give you some equations. Again, you do not need to write this down. We're just going to kind of test our mental graph making skills. So I don't want you using your computers right now either. I just kind of want you to use your brains. So here's my question for you. And again, please do not shout out any answers. If I wanted a graph that looked like this, which of those 4 equations would give me a graph that's curving upwards like that? Again, don't shout out answers, just think. Is there just one of them? Is there more than one? Which of those 4 equations would give me a graph that would look like that? You got an answer in your head? Let's see how we're doing here. Does anybody want to give me one of their answers? A is one of them. How did you know that A was going to be a graph that's curving upwards? 3.2 is bigger than 1, isn't it? Are there any others? D also has something that's bigger than 1, right? So A and D. Any others? Just those 2? How many people were thinking A and D for that quiz problem? Oh, nice. Okay, quiz problem number 2. If I wanted a graph that was curving downwards like this, which of those 4 equations could make me a graph that had that kind of shape? Don't say it out loud, just think in your head. Is there one? Is there more than one? Lock your answer in your mind. Can you stop playing on your phone and participate, please? Thank you. Which one of those equations is going to give me a graph that looks like this? Anybody want to be bold and volunteer an answer? You think it's B? Anybody want to agree with B? What is it about B that makes you think that it's going to be going downhill? 0.8 is smaller than 1, isn't it? So B. What about C? -6 is smaller than 1 also. That's going to give us dots because why? Because it's negative. Yeah, we don't want this to be negative. It can't be less than 0. Perfectly said. Can't be negative. So not C. C is not going to make us any kind of useful graph. Not at this point in our math careers anyways. All right, you guys feeling pretty good about our first learning target for today? That's it. If you were able to answer A and D for this one and B for this one, then you got half of what I need you to understand today. You're doing great. Does everybody have a calculator? If you don't, could you please grab one? We're going to need these. And so that we're all on the same page, could you all hit the mode button on your calculator? Now, if you've got a different one than these yellow ones, you guys don't have a mode button, so don't worry about this. You'll be fine. It's okay. It's okay. I don't think you do. Do you? Our mode button's up at the top. Could you please put your mode, if you go all the way down to the bottom, could you please highlight math print and hit enter if you're using one of the yellow calculators? One of the advantages of these over the other types is that these will do fractions. So when I put it in math print, it's gonna give all my answers in fractions instead of decimals, if that's possible. So that just makes things a little easier. If you don't have one of these, that's okay. It's not a big deal. Yours probably does fractions too. It's probably just a little bit more complicated. So, all right. I want you to look at this equation. Look at number 3 here. Look at this equation. And I showed you the graph of it, but if you looked at this equation, would you be able to picture what that graph's looking like? Is it half bigger than 1 or less than 1? So could you have guessed that the graph was going to be going downhill like this already? Awesome. Tell me, what is the value of this function when x equals 2? The function is y equals 1/2 to the x power. If I put 2 in there, what am I going to get? Now, a lot of you can probably do this in your head because you're just squaring the 1 and squaring the 2. What's 1 squared? And what's 2 squared? So 1/4 is the answer, but let's make sure we can do it in the calculator also. Can you guys clear out of that and go parentheses 1 divided by 2, and then get yourself an exponent of 2 on there. Remember, your exponent is this kind of upside down V looking button. And if you're in math print, it should come up to say 1/4. Now, if you've got a calculator that doesn't have that math print feature, yours is going to say a decimal. It'll say 0.25, which is the same thing. That's fine. What's going to happen if I put 5 in for x? If I put 5 in for x, we're going to get, well, it's going to be 1/2 to the 5th power. I know that 1 to the 5th power is just 1. Does anybody know what 2 to the 5th power is? 2 times, so I got to count it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Is it 1 over 32? Can anybody with a calculator please confirm that for me? It does come out to 1 over 32. Cool. All right, what if we put 100 in here? What's 1/2 to the 100th power? It's going to be 1 over something, right? What is 2 to the 100th power? Two to the 100. All right, I'm going to help you guys write this down, okay? So we're going to just write these same digits on the bottom of our fraction, but we'll leave the decimal out. So copy those down. Write small, though. 126766506. Okay. And our decimal used to be right here after the 1, correct? We need to move our decimal this way, and we need to do it 30 times. So 1, 2, 3, 4, 5, 6, 7 gets us to the end of this. I need 23 more times, so I'm going to need 23 zeros after this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's what that number is. Sure. Can you see it? Sometimes it's hard with these screens. They don't show up very well. I got a question for you. Is this fraction a really big number or a really small number? If I take one cookie and I divide it up into this many equal pieces, are those pieces going to be really huge or really, really, really tiny? Very tiny, right? So this number is really small. So here's the big idea, guys. Two big ideas. As our x values get bigger and bigger, can I get you guys to look up here? This is our second big thing for today. You guys already got the first one. You did awesome with it. Don't miss this. As my x values get bigger and bigger and bigger, what happens to my y values? They get smaller and smaller and smaller. Now, this is a key question. Put that phone away right now. Take your earbud out. Don't miss this, all right? This is key. Is this y value ever going to get to 0? It is getting smaller, but will it ever be equal to 0? It's always going to be 1 over something, right? And that number on the bottom is going to keep getting bigger and bigger and bigger, which means 1 over a big number is going to get smaller and smaller and smaller. But will it ever get to 0? Is there a number you can divide 1 by that's equal to 0? No. It's never actually going to get there. So this graph, it's got a little arrow that shows you that it's getting smaller and smaller and smaller, but this is kind of weird because it never actually goes past the x-axis. Never even touches it. It just keeps getting closer and closer and closer. And we've got a name for this. This is our second big concept of the day. If a graph gets really, really, really close to a line, just absolutely super, super close to it, we call that line an asymptote. And we usually draw them as a dash line. Can you guys please draw a dash line for me down along that x-axis? This is going to be our asymptote. Asymptote. And the asymptote is not part of the graph, but it helps us to draw the graph, and it sort of creates a frame for the graph. So we'll be writing equations of these graphs, but we will also be writing equations of the asymptote that the graph follows. This particular asymptote, since it's a horizontal line, is going to be just y equals some number. Anybody want to guess what the number is for this asymptote? Y equals, where does that horizontal line cross the y-axis? 0. So the asymptote would be y equals 0. All right, so let's answer part B here. Does the graph have a x-intercept? Does it ever cross the x-axis? Yes or no? No, it does not. It gets really small, but it never goes negative. It never gets to 0. And when that happens, we call that an asymptote. And in this case, it's a horizontal asymptote. This last question is kind of right now, we're just going to treat this as a gut instinct question. Do you think that this graph would have a vertical asymptote also? Do you think there's some vertical line here that the graph gets really close to but never quite makes it to? What do you think, yes or no? Give me a thumbs up or a thumbs down. This is just a 50-50 coin toss, folks. Half of us are going to get this right, half of us are going to get it wrong. It's okay. The question is, do you think there's a vertical line also that this is going to get really, really close to but never quite make it to? I think yes or no. The correct answer is no, actually there's not. This is going to get super, super steep. But it's always going to keep moving to the left. So it will always, if I draw any line out here, it will eventually cross it. It's going to be way, way super huge when it crosses it, but it will cross it. If you didn't get that right, that's okay. That's like a calculus question. So the answer is no. The answer is no. Another way to think about the answer is, what are we allowed to put on an exponent for a number? Can we put positive, is it possible to have a positive exponent? Yep. Is it possible to have a negative exponent? Yep. Really huge exponents, really small exponents? Yeah, actually any number can go in for an exponent, which means we're always going to be able to go all the way to the left and to the right. That's okay if you didn't know that. Hey, flip over onto the back page. I made a little study guide. This is going to have all of our key information. This is actually the second to last page. Our big key information today is, how can we look at a graph and tell whether it's increasing or decreasing or constant? Could you kind of, in your own words or symbols or whatever is going to work best for you, go ahead and sketch yourself a graph of an exponential increasing and decreasing, and then something that's just going flat at 1. And over in this space here and here and here, describe the kind of B values that would give you those sorts of graphs. What are you looking for? How did you know which one of these was going to be increasing and which was going to be decreasing? And we didn't have a constant one on here, but what would you be looking for to see if it was going to be constant? How did you know, if I were to give you one of these equations and ask which one's going to look like this, what would you be looking for in the equations to know it was going to be looking like this? Yeah, write yourself some notes down here. There's lots of different, we're basically copying the notes from the page we were just on, up at the top. You got some options. I wrote it as an inequality with a little alligator. Some of you wrote it in words. Whatever, this is your notes, right? This is what you're going to be studying before our next test. So write something that's going to be helpful to you in 4 weeks when you're looking this over before our next test. I like inequalities. I might write B is bigger than 1. Or I might write out the words B is more than 1. Or maybe I draw a little picture showing that B is bigger than 1. I don't know. And that's going to be it for us today, guys. You did awesome with our lesson. I appreciate your attention. Our assignment is basking in the sunlight over there. You see it right next to the tray. You're welcome to go ahead and grab yourself a copy of that. If you're going to get up, grab one for the folks sitting near you. You are free to move and sit wherever you like in the classroom. I'd love you to be working on that assignment. Actually, can you grab me one of those really quick? I want to give you guys a hint on this. Thank you. Appreciate it. I would like to give you guys a hint, so make sure you got a copy of the assignment so you can get this hint. My students were kind of struggling a little bit, 5th period today, to get started on this first one. It's been a little while since we've seen problems like this, so I want to give you a hint to get you rolling. Once you get moving on this assignment, there'll be no stopping you. Everybody got a copy? Are we ready for the big hint? It's going to make your life a lot easier if you pay attention here. All right. Read through the word problem there. Read through those first couple sentences about Rhonda and Khalil. And I would say that this word problem is one of those types of word problems where you've got sort of two categories of stuff. What are the two categories of stuff going on in this word problem? What are the two words that you keep seeing repeated over and over and over again? Soup and bread. I'd say that this word problem is about soup and bread. Okay? Shh. Pay attention, please. I know that when I have word problems that are about two kind of categories of stuff, we often end up writing an equation that looks like this. Actually, we end up writing a set of equations, a system of equations that looks like this. So we're going to write a system here for part A. In order to do this, though, we better define which one we want to be x and which one to be y. Which do you want to be x, the bread or the soup? You want the soup to be x? Okay, well, I heard soup first, so I'm going with the first one I heard. Soup is x and bread is y. If you want to go different, that's fine. You could be using b and s if you want. I don't like usually using b's and s's because my s's look like 5s and my b's look like 6s. I like x's and y's better. We're going to write an equation for Khalil and a new equation for Rhonda. So read Khalil's sentence. Khalil buys 4 cans of soup and 3 loaves of bread for $11.67. Tell me, where's this 4 going to go? 4 is going to go with x because x is soup. Put the 4 in front of the x for Khalil's equation. How about this 3? Where's that going to go in our equation, in Khalil's equation? 3 goes with loaves of bread. Bread was y, wasn't it? So put the 3 in front of the y. 1167's got to go at the end because that's the only space that's left for it. Why would it go at the end? Does that make sense that things are adding up to equal 1167? Yeah, it's the total amount Khalil paid, right? So it makes sense that we got stuff adding up to equal 1167. You're going to need to write another equation, one for Rhonda, and then you're going to need to solve this system of equations. But that's cool. You know how to do this. Which of our 3 methods do you think we'll use? Equal values, substitution, or elimination for this one? Probably elimination. Everything's kind of nicely laid out for elimination. All right, now I have one more hint to give you before I let you go on this. X is soup and y is bread, but what is it about the soup and bread that x and y are representing? Is it representing how many cans of soup, or is it representing how much each can of soup costs? How much it costs. We already know how many cans of soup there were, right? Our goal here is to figure out how much it costs. Now, when we're talking about the cost for something, do you think it would be okay if it ends up being a decimal? Is that going to freak you out if you get a decimal for x or for y? It shouldn't, right? Because you see decimals in your prices all the time. Right? Bottle of soda costs $3.29, 3.29. So if you end up seeing a decimal for your answer, and you will, don't freak out because that makes sense for this. All right, you guys get after it. Let me know if I can assist you in any way. Thank you for your attention. I will put your